Welcome to Key Skill 5. In Key Skill 5, we're looking at numerical approximations using your binomial expansion. This is usually the follow-on question. If the part A has been find the expansion, this might be the part B. Using your expansion, find an estimation for a number. So you're going to start out like before with working out your expansion. In this question, we haven't been asked for the full expansion. Remember, power 8, there would be 9 terms. There's always one more term than the power. So there'd be 9 terms in that expansion, but we've only been asked to find the first 4. Now we are finding multiple terms, so we're not going to use our general term. We're going to use our column method. So I would set it up like this. I've got 1 plus 2x power 8. So the first column, I would start 8 on 0. So 8 choose 0, I need 4. So 8 choose 1, 8 choose 2, and 8 choose 3. The second column is going to be my 1. Now remember, 1's actually not going to be important because 1 with any power is always 1. You need to remember that for later on. So I'm going to write it in just so we can see how it all should be laid out really nicely. And the last one, I'm going to start with my x term here. I've got 2x. I'm going to start it off in 0 and go up from 0, increasing it. And again, that would depend on your question if they said increasing or decreasing. So I'm going to have 2x starting on 0. Remember, you can always check 8 plus 0, it's 8. This one's going to be increasing by 1. 7 plus 1 is also 8. 2x. Okay, so let's work these guys out. 8 choose 0 has got to be 1. Anything choose 0 is 1. So this is going to be 1 times 1 times 1, which is just going to be 1. Remember, anything power 0 is also 1. 8 choose 1 is going to be 8. That was one of our rules in the earlier key skills. N choose 1 is always n. In this case, we've got 8. 1 power 7 is 1. And 2x power 1 is 2x. So here we'd have 8 times 1 times 2x, 16x. So we're just rehashing this. I'm going to fast forward through this now. We're just rehashing what we've learned in a previous key skill. Okay, so I've been asked for the first 4 terms only. So I'd have 1 plus 16x plus 112x squared plus 448x cubed. So that's just what we've previously learned. Now, it says, using your expansion, find an approximation. That's a rough or a guess or something close to 1.02 power 8 using our approximation. So we need to think, what must the value of x be? So we've got the expansion for 1 plus 2x power 8, and we've been asked to find an approximation to 1.02 power 8. So if you think about it, we can take off the brackets and think, what would x need to be? I subtract 1, that would give me an answer for 2x, would be 0.02, and I can divide by 2. That means that I need to use the value of x equals to 0.01 in my expansion. Take your expansion. Now remember, this isn't the full expansion, so you're going to want to put wavy brackets to symbolize that this has been an approximation. And substitute everywhere, x is 0.01. So 1 plus 16 times 0.01. And you want to be laying it out like this for the examiner so they can see. And you're going to collect all those delicious method marks. If I was going to type this in a calculator, the quick way I would do it like this. I would type 0.01 in and store that to be x. Okay? So now whenever I press X, I get this one. Then I would type this equation in using the alpha key. If you find that too stressful, you could just type it in like that. But you're just going to waste a bit more time. But It's not the end of the world. So this gives me an approximation, which is 1.171244. I've been asked for a degree of accuracy that's 4 decimal places. So 1, 2, 3, 4, I would put a line there. So my approximation is going to be 1.1712. Now, I wonder how accurate that is. If we were to have the perfect answer for 1.02 power 8, it would be 1.02 power 8. The perfect answer, imagine if we put that x in to all of those 9 terms, would be 1.171659.381. So looking at our answer, we were really, really close. Now, we can actually calculate how far out our answer is by calculating the percentage error. I've seen this come up. Not too often, but I would definitely know how to use it. If this is the perfect answer, and our answer that we rounded to 4 decimal places is 1.1712, that means that we are 0.000459, etc. out. So that's what we call our error. The formula for percentage error is what's your error, so how far away were you from the perfect answer. Let's say 4 times 10 to the minus 4, divided by what was the perfect answer. In our case, the perfect answer was 1.02 power 8. So we can do this number divided by 1.02 power 8, the perfect answer, and times by 100 for a percentage. So we had a 0.039 percentage error, so a tiny, tiny error. So to summarize that point, although we've only used the first 4 terms, we've got a very accurate answer. We've got a very accurate answer because if we have x as a number smaller than 1, the higher the power is, the smaller the number is going to be. So, for example, even imagine at x power 9, you're dealing with tiny, tiny numbers. Whereas, imagine that we just used only the first 2 numbers. We just used 1 plus 16x. Well, 1 plus 16x gets us to 1.116, using the first 2 only. Remember, the perfect answer is 1.17, and some change. So each one of these will contribute more greatly to the answer. And as the powers get higher, the numbers become so small that they're practically 0. So we're adding on very, very, very little bit by using the higher powers of x. Guys, that's all I want to say about this. There's plenty of examples of this in the past papers. Make sure that you're on our website with your profile and putting all your answers into your questions, and I'll see you in the next key skill. In the next key skill, we're going to be looking at how you can deal with 3 things in a bracket or double brackets. So I'll see you then. Bye for now. Enjoy your tea break.